In this video, I'm going to be outlining how to make an astable oscillator. But I think the cooler news here is this is going to be the first video in a series in which I aim to make an induction heater and a very high wattage amperage heater. However, I don't currently have all the knowledge I require. I'm going to need to work my way up there. First, we're going to start with just a simple astable oscillator. The idea of this is to get something that without input will oscillate back and forth. For this, you're going to need a number of capacitors and a number of resistors. Then I'm going to use two LEDs to show that the oscillation is going on. And then the workhorses here are going to be two NPN transistors. And then obviously they need some sort of power supply. Something that I'll note is that I have 4 different sizes of resistors and capacitors here. And each of these are the same size. That's important because we're going to be using these in pairs. First, I'm going to set up my ground circuit and my positive circuit. Alright, well here we have what I was talking about. Off the positive side of the battery setup, we just have a strip here that's going to be positively charged, and then connecting to the negative. Now connected to the negative, we have something that runs around the outside, and that will help with grounding. And then we're going to use the middle here for the work. First, we're going to set down our capacitors, and the smaller they are, the faster this is going to oscillate. So I'm going to go ahead and put some very small ones down, and I can stack a larger set on top so that they can work in series to act as a larger capacitance. From here, we're going to set on a set of resistors here and then a set of resistors here. They're both going to be the same size, so these will be the same size and these will be the same size. Something that I think is important to note is this ones that we set here are going to just apply straight to the LED. So we're just going to use those to limit the amount of current that's going to the LED. In this case, I only need 100 ohm resistors. However, these ones are going to determine how fast your capacitors charge and will again affect how fast they resonate. And for these, I'm going to use some 5,100 ohm resistors, or 5.1 kilo ohm. The critical part upon which all of this depends is the fact that each transistor, when it's turned on, is going to be charging the other capacitor. That way, as soon as the voltage rises above the threshold on this, it will now want to go through here and turn this one off. I'll explain all that more in just a second, but basically that's how you achieve constant back and forth. At this point, we have our actual load circuit set up. So if you note, if I were to short this out, for instance, I'm going to short out this one. Oh, turn it on. I'm going to short it out, light turns on, short it out, light turns on. So all we now need to do is set up exactly how this is going to switch back and forth. And for that, all we have to do is attach this gate to the opposing capacitor. So this gate needs to go to this capacitor, this gate needs to go to this capacitor. I'm going to now use a 470 microfarad capacitor, which is significantly larger. And now, when I switch it on, there you have it. You're going to have some initial fast ones while it charges, and then you're going to have a nice, steady rhythm of it alternating back and forth. Now I just want to show you the difference between a couple configurations. Alright, well at this point our circuit has the clicking chips and then the LEDs for the load, and then I've got doubled up capacitors to increase the amount of time it takes. Now I'm going to turn the circuit on. I'm going to be quiet so that you can hear the click. So you can hear the click there. Well, now what I'm going to do is I'm going to take off these larger capacitors and I'm going to install the next size down, which is 100 microfarad. And what you're going to notice is that the clicking is again louder. Finally, I'm going to install C2. These are just 0.1 microfarads. And at this point, the whistling chips are going to be playing a note. Here it goes. And finally, higher pitch. And now the pitch is so high because the capacitors are so small and they charge so fast that we can't even hear it. All right, well, I appreciate you guys taking time and watching this video. This is the first in the series of working on astable oscillators, and then ultimately we're going to work our way up to a very large induction heater. This here just shows that we can achieve astable oscillation. Next, what I want to do is add MOSFETs or IGBTs, which will make it able to oscillate faster and with a lot more current. And from there, we'll add some inductors and we'll get some resonation going, and that'll again be in the next video, so you guys watch out for that. Thank you.